This capstone is the centerpiece of your evidence as an agentic AI engineer. Agentic AI is a portfolio-led role with no dominant certification, so the work itself is your proof. In this lesson, you take a working multi-agent system and raise it to portfolio grade, a LangGraph design with real tools and memory, an evaluation harness with quantified results, captured traces, and a reproducible repo a hiring manager can run and trust. The bar is not the biggest model. The bar is reproducible, evaluated, and defensible. The difference between a demo and a portfolio piece is not the model or the number of agents. It is reproducibility and proof. A demo runs once on your laptop. A portfolio piece ships with a design doc, a clean repository, an evaluation harness with real numbers, traces that show how it behaved, and a README that lets a stranger reproduce all of it. Hold yourself to that bar. The question every reviewer asks is simple: can I clone this, run it, and verify what you claim? If yes, you have proof of skill. Start from a user outcome, not a framework. Choose a task that genuinely needs cooperating agents, a research analyst that plans, retrieves, drafts, and critiques, or a triage system that classifies and resolves. Before any code, write a one-page design doc: the problem, 3 to 5 user stories, the agents and their roles, the tools each may call, the topology, and the stop conditions. Add a clean diagram. Crucially, state the trade-offs you chose. The sentence: I used a supervisor rather than a peer-to-peer network because control flow stays inspectable, is exactly the judgment interviewers look for. Implement the system in LangGraph with type state and explicit nodes and edges. Keep it to 2 to 4 agents, because each extra agent multiplies the failure surface and the cost of every run. A supervisor delegating to specialists is the safest default. Control flow stays inspectable, so the system is predictable and easy to narrate in an interview. Give each agent a tight contract, a clear role, a small set of allowed tools defined with function calling or exposed through an MCP server, structured outputs, and a stop condition. Validate tool arguments and outputs, and apply least privilege to what each agent may call. Most useful agents need grounding. Add retrieval augmented generation over a real corpus, chunk the documents into roughly 500 to 1,000 token pieces with overlap, embed them, and retrieve the top K with a metadata filter or re-ranker. Always carry source citations through to the answer, because without them you cannot measure faithfulness, and citations also make the output trustworthy. Add memory in 2 layers. Short-term memory is the in-session scratchpad LangGraph threads through your graph. Long-term memory is a persisted store of user facts, with a summarization step so it never grows without bound. Do not ship on vibes. The evaluation harness is itself a portfolio asset almost no junior candidate has. Here are 20 to 50 cases covering typical inputs, edge cases, and known failures, each with a checkable acceptance criterion. Measure outcomes like task success rate and format compliance, and trajectory quality like tool call accuracy, step efficiency, and error recovery. For qualities with no cheap check, use an LLM-as-judge with an explicit rubric and structured output, defending against position and verbosity bias. Treat cases like unit tests. When you find a failure, add it so it can never silently regress. Instrument the system so every run records each node, tool call, argument, observation, token count, latency, and cost. Tools like Langsmith, Langfuse, or OpenTelemetry make this routine. Traces do 3 jobs. They make failures debuggable, leading you straight to the broken step. They are the source of your process metrics like tool call accuracy and cost per run. And they are evidence. A screenshot of a trace in your README or demo shows a reviewer exactly how the system reasoned, which is far more convincing than a final answer alone. Before you call it done, score your project against 7 rows: problem fit, architecture clarity, implementation quality, evaluation, observability, reproducibility, and communication. Any weak row is your next commit. Report real numbers in your README, like task success 86% on a 40K suite, tool call accuracy 94%, and 4 cents per run. Make it reproducible with one command to install and one to run, secrets injected through environment variables. Record a 3 to 5 minute demo, and write an honest limitations and next steps section. A project strong across all 7 rows is the artifact that ends an interview with "When can you start?"